Welcome to the third video in a series that explores topics in cybersecurity by using a Linux virtual network. In this video, we're going to look at the topic of hardening. Now, back when I was studying for the Security Plus, I was using Jason Dion's course, and he had this definition of hardening that I still refer to this day. And the way he put it was that hardening is the act of configuring an operating system securely by updating it, creating rules and policies to govern it, and removing unnecessary applications and services. Now, there are a lot of ways to go about doing the things that I do in this video, but the whole point of this is just to get acquainted with these topics and do some hands-on, even if these ways are not the best or most efficient. Later on down the road, you can always come back around and improve your methods and do this in more current or more efficient ways. Now, where the methods that I use in this video are easy enough to pull off with the command line, I've opted not to go real far beyond and look into GUIs or alternative commands for them. I've opted to stick with out of the box as long as I possibly can. So what is this video going to cover? We're going to look at updating software in the kernel to the latest version. We're going to look at managing packages and removing or uninstalling unneeded software. We're going to look at scanning for open ports. We're going to look at locking user accounts. We're going to look at locking the root account, stopping unneeded services, implementing the host-based firewall, hardening SSH. So here we are back in the virtual environment. We've got our Ubuntu machine representing the IT network. We've got our Fedora machine representing the employee network, and we have our pfSense firewall. Now, for the purposes of this video, we need to get some stuff from the internet, mainly to update the packages and update the kernel. So what you would normally do is go here to your settings for your virtual machine and just hook it up to NAT. But I don't know what I did with my VMware workstation setup. I have to set it to bridged, which allows it to connect to my local network as if it's just another machine on the local network. Anyway, what you would do is just set it to NAT. It can connect to the internet. For me, I have to do bridged. So let's just go ahead and log in here. All right, so we're connected to the internet there, and let's go ahead and do this right here. Bridged, yep, it's bridged, all right. And we've got a valid IP address on the local network. So now we've got these machines set up so they connect to the internet, and we can do the demonstration of the different hardening techniques. So the first topic that we're going to look at is updating the kernel and updating the software packages. Now, in Linux in general, which means Fedora and Ubuntu, you want to be mindful of updating both because they can be done separately. So what we're going to do is we're going to perform the same action for both Fedora and Ubuntu, and they're going to do essentially the same thing in two steps. One, they're going to check the repositories for any updates to the packages, and they're going to install updates to both the packages and the kernel. Obviously, the implications for cybersecurity are that the kernel can have bugs, security vulnerabilities, all sorts of things along with the software. Obviously, updating and upgrading these things removes those vulnerabilities and in the end makes your system more secure. Another thing that we have to take into consideration is whether or not messing with packages is going to end up breaking other packages or other software altogether. And the systems for Ubuntu and Fedora, which would be apt and DNF, they're both pretty good about dealing with that. So it's not something that for the purposes of this lab we need to worry about, but of course it's something that you want to be mindful of, you know, as you go on and do this down the road. So in Ubuntu, sudo apt update is going to pull the updated package information from the repositories or repos. And this takes about 30 seconds or even less than that. And then sudo apt upgrade is what actually takes all of that information and just pulled and applies it to to all the packages on the system, including the kernel. Now you can update the kernel on its own, but for the purposes of this lab, we're just going to do both at once. Same thing on Fedora. So let's go ahead and do that. Oh, pardon me. It's a full upgrade. All right. And there we go. So for me, when I did this like off camera, it takes about 5 minutes for Ubuntu to completely upgrade and update the kernel when it's fresh out of the box. So we'll just zoom on to when it does that. And there we have it. Ubuntu, the Linux kernel, and the packages are all upgraded and updated. So now let's turn our attention to Fedora, and let's go ahead and look into upgrading and updating packages on this system too. So in Fedora, what we do here is we use a package management system called DNF. And we do it in 2 steps here as well. So we'll do DNF check update. All right, and that's going to do the same thing that app did, except with the package management system on Fedora. Okay, so it's update information, and we're ready to update all the packages. So in this, we just do DNF upgrade or sudo DNF upgrade, and that will go through and take care of the kernel and the packages for us. Now Fedora out of the box, it takes about 11 minutes, so we'll just start the upgrade process, and we'll skip on up to whenever it's actually done here. There we go. And there we have it. Our systems are both upgraded and updated with the latest security patches, and we have removed different ways for bad guys to take advantage of our systems. So now let's move on to the next hardening point, which would be package management and removing unnecessary software. So it goes without saying that adding software to your system increases the potential for exploitation. So it's important to survey your system and remove packages and software and applications that you're not actually using. So now that we've updated and upgraded our system, let's go through and think about removing some software packages that are on there that we don't actually need. Red Hat or Fedora and Ubuntu both use different methods or different systems for package management. Ubuntu is based on the Debian Linux distribution, which uses a package management system called apt or apt, and Fedora is Red Hat. So it uses a package management system called DNF, which goes back to the RPM or Red Hat package management system. So I provided a couple of good resources in the description for DNF and apt. In this lab, we're going to look at a snippet of that, specifically querying the package database to see what's installed related to a certain what's called a meta package, and removing those packages. So let's take a hypothetical scenario. We found out that LibreOffice has some crazy security vulnerability, and we don't know if it's on our system, and we know we don't use it, but if it is there, we want to get rid of it. So that's what we're going to do. We're going to perform this on Fedora and Ubuntu. So let's get started with Fedora first. So in Fedora, LibreOffice is associated with what's known as a meta package. And a meta package is kind of like a big umbrella for the related packages. Now, if you use DNF to try and find LibreOffice, or if you try to remove LibreOffice using DNF, it's not going to happen. Okay, so we see here that LibreOffice, it doesn't find it because LibreOffice is a meta package. But what we can do is query the database and find out what exactly makes up LibreOffice. So here we go. We've got all these packages that are related to LibreOffice. So we want to just go through and remove all of these. That's a mouthful. Anyway. Yep. All right, so bye-bye LibreOffice. And as a last step, sometimes packages will be left behind that these packages depended on that are no longer needed. So you can do sudo dnf auto remove, and it'll clean up packages like that. So yeah, here we go. All right, so there we go. Next step is to take a look at how to do this on Ubuntu. Thankfully, things are pretty similar on Ubuntu, except there we'll be using apt. So here we do sudo apt remove LibreOffice, and we'll get the same error we got last time because LibreOffice here is a meta package as well. But we can use apt show to see what packages that it's composed of. And there's quite a bit here. But all we really need to do here on Ubuntu is just get rid of these. So writer, calc, impress, draw, base, and math. All right, and then in Ubuntu, we also want to do auto remove to get rid of any lingering packages or lingering dependencies. And there we go. Now, apt and DNF are really extensive, and there's a lot of stuff you can do with them, but we just wanted to, get acquainted with package management, removing packages. There are graphical things that you can use. There's something called aptitude, which is a nice little user interface for the terminal. But anyway, this is enough to get us started. So the next topic we're going to touch on is looking for open ports. Now, we're going to connect back to the local network, but before we do that, we're going to install a program called nmap because that's what we're going to use to perform a port scan. So all right, so the next thing we want to do is go ahead and set these virtual machines up so they're back on the local network. So here we want to go back to what is it, employee network, and over here we want to go back to the IT network. All right, there's that, and we'll just go ahead and perform reroute with the firewall, which will what this will do is it won't completely reboot it. It'll just save us a little time. There we go. Oops. Yeah, reroute. All right. Okay, so we should be able to go back to employee and ping 192.168. Was it 101. Let's see what that is. 101.10. There we go. Sometimes it just takes a little bit of time. Anyway, so the machines can communicate. Now what we can do is attempt to run a port scan on employee from IT. Now, out of the box, Fedora and Ubuntu don't really have any ports open. Also, the firewall does give us a measure of security. So for external attackers, the firewall is not going to pass traffic in the first place. However, it's always a good idea to reduce your attack surface. So if there were things listening on ports that we didn't need, we would definitely want to close those ports off or remove those unnecessary services. But out of the box, the only thing you're going to see running is CUPS, or IPP, which is related to CUPS, which is a printer system. And CUPS only listens on the internal network, but it gives us an opportunity to look at removing unnecessary services. But just for the sake of demonstration, let's perform a port scan externally and then internally. So what we do here is we just run the command nmap with the super user privileges. So we'll do sudo nmap localhost. That will run an internal port scan, and there we see that IPP is up and running on the internal network. And if we were to run that on the Fedora machine, we'd see basically the same thing. But let's go ahead and run a port scan against the employee system. Nmap's not going to find anything because there aren't any ports open for it to find. But we'll demonstrate opening up some ports here in a second. Anyway, I don't know exactly what it is that prevents nmap from being able to scan the host initially, but for the purposes of demonstration, we have to use this switch pn, which just assumes that the host is up. Otherwise, we're going to get an error. Yeah, but if we do nmap pn, then it'll go through and scan it like normal. So let's do this just to demonstrate. We'll go over here to the Fedora machine, and in a minute we're going to look at services and managing services and things like that. But in Linux, Fedora, and Ubuntu, there's an out-of-the-box command we use, system control. Which starts, stops, and manages services and things like that. So right now, the employee machine has SSH running on it. That service is up. So if we run our nmap command now, then it's going to tell us that port 22 is up and running. So nmap is very involved. There's a lot to nmap, but for the purposes of just like getting acquainted with it and scanning ports, experimenting, this is perfectly fine. So what we can do now is move into the next point on hardening, which is removing unnecessary services, starting and stopping services, and things like that. So as I mentioned earlier, system control is the way we go about managing services on Fedora and Ubuntu. And earlier we saw that a service called IPP was running. And that's really, if you do a little bit of digging, you'll find that's related to something called cups. So what we can do is use the system control facility to manage that service. Now, if we just do sudo system control, then that's going to show us all the services running on our system. If we want to find this particular service, see if it's in there, right? So we've looked on the web, say, okay, it's related to cups. Is cups something that's running? And here we see that cups is running on the system. So what we want to do is first stop the service. And then we want to disable the service to just get rid of it entirely. All right, and there we go. And if we go up here and do sudo system control grep cups, we'll find that it's gone. And that's basically how you go about managing services out of the box. And of course, there are most likely other ways, more efficient ways, but this is a good way to get started with dealing with unnecessary services. So let's go move into the next point, which is about locking user accounts. So another way to harden our systems is to lock user accounts. Like hypothetically, there's a user who you don't want to delete their data, you don't want to delete their files, maybe they're going on vacation or something. But anyway, you want to lock the account so that no one can log into it, no one can attempt to brute force it or anything like that. So we've got another account on this system for George Roberts, and what we'll do is we'll lock George Roberts' account. So to do that, we use sudo and then password L. All right, so now what we can do is try to log in as that user. Go to switch account. And we'll put this in manually. And the password. All right, so we know that user's been locked out. So let's go back here and log in as Derek, and unlock the account and then log back into it. Sudo password, whoops, password u, probate. Okay, so now we go here. And George can log in. So his user account was unlocked. And that's pretty much all there is to locking user accounts at the most basic level. The next thing we want to look at is locking the root account, which is another important point in hardening. So another way to, this is also a way to lock user accounts, by the way, but it's an interesting way to show how to go about locking user accounts. But on the topic of the root account, with the root account, locking the root account moves us towards the principal least privilege, which means that someone is not going to use root for everything. They're not just going to admin over all stuff. And also, whenever someone uses sudo to execute a command with super user privileges, then it's actually logged. Whereas with root, all we know is that root executed the command. So one of the methods that we can use to lock the root account is to actually open up the set password file and go in there and change the shell of root to user sbin no login. So we're going to do that using nano. And we'll go over here to the shell for root. This line over here specifies which login shell they use. And we'll just do user sbin no login. All right, so just for demonstration purposes, we've changed the root password to something very simple, but just to show what happens, we'll do sudo-, which means login as root, and that password we just set, and there you go, account's currently not available. So the root account has been locked. So that's another point of hardening. And so the next thing we're going to look at is hardening SSH. SSH is a pretty important part of Linux, and it allows you to remotely log into another machine and execute commands on the shell. Now, it's easy to imagine scenarios where this would be really useful, even, especially in like this network scenario, this lab we're creating here, where IT would need to log into the employee machine and do some stuff. So while it's not enabled out of the box, I do think it's useful to get acquainted with SSH, especially making it more secure and hardening it. So let's go to the employee network here, and we're going to make use of system control to get SSHD going. So I'm going to do sudo system control enable SSHD. And then we want to go sudo system control start SSHD, and then we want to check on the status to show that it's running. So system control status SSHD. There we go. From here we see that SSHD is running. Now we've got SSHD up and running. First thing we're going to do is tweak it a little bit to harden it, to make it a little bit more secure. And what we're going to do is prevent password-based authentication. We're going to rely on private keys. We're going to remove the ability for root to access a system through SSH. And we're also going to change it so that the default port is 1357. And of course, the idea is to slow down attackers, not to completely stop them. Makes it a little bit harder to look for it if it's on a non-standard port. Anyway, let's go ahead and do that. So we're going to go sudo nano, we'll do set ssh, whoops, d, oops, config. All right. Now, first thing we're going to look for here is port. And we want to change that to 1357. That was just kind of arbitrary. But it's past that 1000 number that nmap looks for by default. So I just thought it was a good thing to use. So then we're going to look for permit root for permit root login. And we're going to just say no to that. Permit root login, no. And then we're going to look for password authentication. And we're going to say no. All right, and there we go. So we've secured a little bit, but we're still not through. We still have to add port 1357 to the list of allowed ports. And we have to open up port 1357 on the Fedora machine. And we also have to get a private key over this machine so that the user Derek can log into the machine before we actually prevent password-based authentication. So that's what we're going to do next. So let's go ahead. We're going to use the command sudo se manage, and we're going to add a port. The type is going to be SSH port T. Then we're going to put this flag for protocol, TCP, and then the actual port number. Okay, so that's been added. Now we're going to do firewall command. Anyway, just for the purposes of this demonstration, let's just put this command in. There's a lot to unpack with firewall command, but for right now, we won't worry about it. Zone equals, we're going to do firewall command, or sudo firewall command zone equals public, and then add port equals 1357 TCP, and then permanent. Okay, so now what we need to do, or just to demonstrate that that's actually taken place, first thing we'll do is reload the firewall. So we'll do sudo firewall command restart. Whoops, reload. Okay, so now we'll go back here to IT and SSH 192.168.102.2, and there we go. We get an SSH prompt. Okay, first we want to do SSH keygen, and that's going to generate our private key. And we'll just go ahead and save it with the defaults, no passphrase. Don't worry about that right now. And then we want to send this over to that other machine. All right, there we go. So we've passed that key over. Now we're ready to turn off. We're ready to restart the SSH service and implement those tweaks that we made. So sudo system control restart sshd. All right, sshd has restarted. So if we try to SSH into the remote machine now, it won't let us. But we add the P flag to the end there, port 1357, we're in because of key-based authentication. So what we've seen is just a good way to harden SSH. Always more to it than this, but for starters, I think this is some good techniques to get acquainted with. So let's take a look at the next topic, which is implementing the host-based firewall. So last segment, we looked at Fedora's firewall system in brief. And in this segment, we're going to look at the concept of hardening your system with firewalls, host-based firewalls. We're going to go more in depth into this in the future when we look at firewalls in depth. But for right now, let's just get a little bit acquainted with the Ubuntu side of things, the Debian side of things, which is IP tables, or in our case, we're just going to look at something called uncomplicated firewall, UFW. So UFW is the front end we use to manage IP tables, where, you know, on Fedora, it was firewall command. which was used to manage Firewall D. So we're going to give a short demonstration on how to go about, setting up, managing firewall rules. And it's really cool because UFW really is an uncomplicated firewall. So what I like to do when I'm like testing stuff like this is in Python, you can actually spin up a basic HTTP server, and you can use that to test HTTP connections, and it's just a cool way of going about testing this. So what we're going to do is start up a web server with Python, and it's going to be listening here on port 9000. Now port 9000 is closed, but first let's look at the status of the firewall. So I'm going to do sudo UFW status. All right, so the status is active, and it's currently blocking everything except for port 22. So if we go here to the employee machine, and let's just say we do curl, which is a way, a nice command line way of retrieving information from things like web servers or other services without connecting to it with some kind of client or something. Just curl HTTP 192.168.101.10. Nothing's going to happen. Oh, pardon me, port 9000. Same thing though, nothing's going to happen because it can't connect to it. So let's go back here and let's update our firewall rules. So we'll do sudo UFW allow 9000. There you go. Port 9000 is now open. And we are going to reload the firewall. Sudo UFW reload. Firewall will be reloaded. There we go. And now if we go here, there, boom. We just got what comes back from that minuscule Python web server we set up. So that's, of course, the whole idea is hardening. This is just demonstrating UFW in action, but there's not really much on Ubuntu out of the box as far as firewall rules that you really need to harden. Of course, port 22, port SSH port. This is the IT machine, UFW. If you want to know what firewall rules you have in place, you do sudo UFW status numbered. That'll tell you what's active, and as you can see here, we got those rules we created. And if you just wanted to get rid of one of these, you can just do sudo UFW delete and then the number. So you do that, yes, and then we can do number 4. Whoops. Of course, it's going to be number 3 now because we just removed that. But anyway, and eventually you go on and just remove the rules. So that's firewalls in it. It's a really superficial look at firewalls, but of course firewalls are important for hardening, and it's important to know how to do this out of the box. So there's that. So that was a bit of territory that we covered. We looked at a lot of points that come up when you're thinking about hardening, and super secure systems are going to need so much more hardening than this, but at least this gets your feet wet with the concept. You can't go wrong by learning about how to mess with UFW, and you can't go wrong by being exposed to firewall command and all the stuff that we've covered here. These are really good things just to do some hands-on with, get some practice with as you make your journey into cybersecurity. So I'll see you, pals.